Okay, so in this video, we're going to see if we can get a better understanding of what's happening with switching and routing. Thing is, if you already know about Ethernet, switching, how routing works, and all these things we've talked about previously, VLANs, broadcast domains, you really know everything you need to know. You know all the answers. You even know the right questions to ask. We just have to ask them in the right order. So this is an attempt to kind of help explain and help us understand, better understanding of what's going on. So let's say we have this PC here at 10.10.1.100 has a packet to send to down here 10.1.1.101. Now it knows its source MAC address, but it doesn't know the destination MAC address. So of course it looks in its ARP table. It's not there. So let's go ahead and do a ARP request. So an ARP request, here we go. Basically asking the question, who is 10.10.1.101? Coming from the source MAC address of this device here, 10.10.1.100, and the MAC address, destination MAC address is a broadcast. So let's begin with this. I'm going to use my little ink to go here. So it comes in on this port. Remember, the PC has no concept of VLANs, right? It just knows that this device it's trying to reach is on the same network as itself. So it can do an ARP request for the IP address of the destination IP address. Okay, it's an Ethernet broadcast. What does the switch do? Well, it came in on a VLAN 10 port. So it's only going to send it out VLAN 10 ports. There's the wonders of VLANs. It segments broadcast domains. So it is not going to send it out this port here. Forget that. But there are two ports, and this here's a combination. Well, that's one of these links is not being used because of spanning tree, but that's for another video. So let's just assume this is one link here. All right, we have two trunk links, both which are enabled for VLAN 10. So what happens is a little tag gets put on here for VLAN 10. I'll just put a T there, and the broadcast gets sent out this way. Same here, little tag for VLAN 10 gets inserted, 802.1Q. Okay, it reaches this distribution switch here. The tag gets unremoved, gets removed. Not unremoved, gets removed. Gets untagged is what I want to say. Okay, so this switch here recognizes that this was a broadcast. It came in with a tag for VLAN 10, so it's only going to send it out VLAN 10 ports. Well, we don't have any access ports that are VLAN 10, but here's another trunk link. So it's going to send it out this trunk link here, again, tagged as VLAN 10. Now, it is not going to send it out this link here. Remember, routers, and that's what distribution switch, one switch is. It's also a layer 3 switch, which makes it a router. Broadcast domains are segmented to that local area network. They're not sent out other networks. Okay, so let's just continue this. Let's go down here. Let's continue this. I'm sorry. Reaches here, gets untagged by this switch here. The switch recognizes that it came in on a VLAN 10 port. Again, notices it's a destination MAC address is a broadcast. It's only going to send it out VLAN 10 ports. So it will not send it out this port, segmenting broadcast domains, does send it out this VLAN 10 port, and does send it out this trunk link tagged as VLAN 10. Okay. Arrives at this switch here that untags it. It notices it came in tagged as VLAN 10, untags it, says I'll only send this out VLAN 10 ports. So I won't send it out that port, but I will send it out this access port. Okay, how about over here? Remember, way over here. It got tagged going out this trunk link as well. Gets untagged coming into this access switch here. The switch recognizes it had a VLAN 10 tag. Again, destination MAC is a broadcast. Will not send it out this port because it's not VLAN 10, but we'll send it out this port. So we could see here is our segmented broadcast domain. Okay. where we have the trunk links and access ports on VLAN 10. Now, in this case here, this device here will reply and say, yes, here's my, my IP address, here's my MAC address, and send that back to this device here. So it will now have the MAC address associated with this IP address and can put it right here. Let's kind of cover that just briefly here. I think that's fairly straightforward, but that Ethernet frame will come in here. Okay, destination MAC address will be associated with this device here. It's a unicast. Okay, it will get tagged as VLAN 10. Come up here, get untagged here. This switch notices that it came in tagged as VLAN 10, removes the tag, and will send it out this port. Now, these two switches, just want to mention here, did not have to send it. Well, it's never going to send it out this port, but this switch here never sent it out this port here like the broadcast. And we're assuming, and I think rightfully so, that the switch's MAC address table had learned the MAC address of this device here. So when the Ethernet frame came in for that destination MAC address, it knew what port to send it out of. All right, so I hope that explains a little bit about one device sending to another device on the same VLAN, same IP network. Okay, through the magic of pausing the recording, this time we're going to go from 10.10.1.100, same device, but we're going to go to 10.21.100. So, let me put let's see, let's change that here. Sorry, 1 second. Let me just make sure we have the right IP address. There we go, 10.21.100. So in this case, our PC here sending the packet recognizes, hey, we're on two different IPv4 networks. So I can't reach you directly from my NIC card to your NIC card. I have to go through my default gateway. Now, the default gateway for this device, let's actually bring that up, desktop. We can see right here. The default gateway is 10.10.0.1. Okay. All right. So 10.10.0.1, that's actually the switch virtual interface, interface VLAN 10 on our distribution 1 switch. Our layer 3 switch acting as a router. In this case, the default gateway for this device right here. Oh, let me close that. All right. So what this device here, let's go back to my ink to go. Okay, so what this device right here is going to do is it recognizes, hey, we're on two different IP networks. I got to send this to my default gateway. It knows the IP address of its default gateway, as we just saw. But let's say it doesn't know the MAC address. It checked its ARP table. The MAC address associated with that default gateway address, 10.10.0.1, is not in its ARP table. So once again, it's going to send out a broadcast. So let's just do this real quick. Broadcast goes out here. Here's the broadcast here. It's a destination MAC is a broadcast. It's a ARP request. Who is 10.10? Oh, Rick made another mistake. Okay, that's all right. We'll fix that real quick. There we go. All right, 10.10.0.1. Okay, so it says who is 10.10.0.1? Again, the switch sees that this is a broadcast, will only send it, and that came in on a VLAN 10 port, will only send it out VLAN 10 ports. Does not go out this port. It does go out this port here. Again, gets tagged as VLAN 10 here, gets untagged here, goes out, does not go out this port here. This switch, when it receives it, will only send it out VLAN 10 ports. That's why it's not sending it out this VLAN 20 port, and will send it out this port here. Okay. it will send it out this port here, tagged as VLAN 10 and untagged here. Okay. Now this switch actually will continue to send it. So it's okay, acting as a switch. I'm going to go ahead and, yeah, since this is a broadcast, I'm going to tag it, VLAN 10, untag it here. It's just a typical Ethernet broadcast. This switch here receives it, says I came in on tagged as VLAN 10. I untagged it, but I will only send it out VLAN 10 ports. Will not send it out this VLAN 20 port. Trunk link, I'll tag it as VLAN 10. The switch sees, oh, got a frame here tagged as VLAN 10. I'll untag it, but I will not send it out VLAN 20 ports. I'll only send it out VLAN 10 ports. Okay, although we did that previously, it's always nice to see this again. But this device goes, hey, I'm 10.10.0.1. I'm what you're looking for. Okay, just like any other device on our network, in this case, like our router on our network. So what it's going to do, let me remove this here, is it will send back an ARP reply. Okay, it will send it out just this port, because acting as a switch, it knows that the source MAC address came in on this port here, and so it will only send it out this port here. It does get tagged as VLAN 10, untagged here. This switch removes the tag, looks at the destination MAC address. It had learned it from the ARP reply, so it will just send it out this port here. And this device now has the MAC address for our for its default gateway, which it can now use to send the packet. Okay, so let me clear that up. Okay, so now we're at the point where this device here has the MAC address associated with its default gateway, which is the switch virtual interface on distribution 1, 10.10.0.1. Let me just show you this. I think this is interesting. Let me do show interface. I think I've actually, here we go. Show interface VLAN 10. Okay. So we can see the IP address there, and here's the MAC address associated with that IP address. So this is what this device here, our PC, will have in its ARP table for 10.10.0.1. If you're curious, if we do VLAN 20, notice that it is actually a different MAC address. I believe this last number is different, if I remember correctly. Yes. Okay. All right. That last hexadecimal digit there. So the layer 3 switch will have a different MAC address associated with each one of its switch virtual interfaces. Okay, so let's kind of move ahead on this here. So the packet is now being sent in an Ethernet frame to the default gateway. Again, hits the port here, VLAN 10. I think we know that's going to get tagged here, untagged here. The switch in its MAC address table knows the MAC address associated with the destination MAC address here. Okay, because it learned it via the ARP reply. So we'll make that assumption. I think it's a pretty good assumption. All right, so now when this distribution 1 switch here gets it, it notices, hey, this is MAC address. This is me. That's my MAC address associated with my SVI. So I'm not acting as a switch now. I'm acting, in this case, as a router. So what it's going to do here is de-encapsulate the frame. All right, so we'll just say it gets de-encapsulated, and then it's going to look up the destination IP address in its routing table. Let's take a look at that. Let's do show IP route. And it says, let's see, this is for 10.20.0.0. You're my best match. You're directly connected to me. I don't have to send it out my routed port. You're on one of my directly connected networks. This means that either I have an access port on VLAN 10 and or trunk links. And I actually have 2 trunk links that belong to VLAN 20. So what happens next? Well, let's take a look. So now what happens is we're here at distribution 1. Okay. It wants to send this to 10.20.1.100. But let's say it doesn't know its MAC address. Okay. So it's going to have to send out an ARP request. Okay. For who is 10, that's right, get these right here, 20.1.100. Okay. Because you're not in my ARP table this time. All right. Oh, all right. So what it's going to do is send out a broadcast. And I want to go through this because this is important. It's all important. It's all good stuff. But you know all this. Okay. It's going to send out an ARP request out VLAN 20. Now we see where it is, right? But remember, these devices are end devices, our switches, our routers, our layer 3 switches all live in a bubble. Okay, it doesn't see where it is, but it says, hey, I've got 2 trunk links that carry VLAN 20. I don't have any access ports, just trunk links. So I'm going to tag this going out both ends. This is a broadcast I'm sending out. Who is 10.20.1.100? I know you're on my directly connected VLAN 20, so I'm tagging this as VLAN 20. Okay. So that's where this goes in, by the way. There's a little tag here. I haven't been showing that, but that's where the tag goes. Okay. Let's go this way first. Gets untagged here. Another Ethernet broadcast. This time it was tagged for VLAN 20. I untagged it, but I'm only going to send it out VLAN 20 ports. I'm not going to send it out this VLAN 10 port. I will send it out my trunk link because this is enabled for allows VLAN 20. Tag it here. This switch untags it, recognizes it came in on a VLAN with a VLAN 20 tag, sends it out only VLAN 20 ports. After it untags it, does not send it out VLAN 10 port. Here we go over here. The broadcast comes in here. The switch here untags it, sends it out only VLAN 20 ports. Will not go out here. I'll tag it here as it goes out this trunk link, tagged as VLAN 20, untag it here. Won't send it out the VLAN 10 port. We'll send it out the VLAN 20 port. I think you're getting the hang of this. Okay. Everybody ignores it except for this device here that responds with its ARP reply. Okay. So now let's kind of do that real quick here. This device here sends back the ARP reply. The switch says, oh yeah, I know where that destination MAC address is. I'll send it just out this trunk link here, tagged, untagged. Our router gets it, says, thank you very much. Now I can put your MAC address right here. Okay. So we'll just say, I'll put a B here for PCB. Okay. That's PCB's MAC address. And now it can send it out just, so let's just finish this up. So now the packet with MAC address of PCB goes out this port here. The switch now knows, says, yes, I learned where B is. I know the switch part of me says, I know just to send it out this link, not this link. Tagged, untagged, received by this switch. Says, oh, okay, yes, you're a VLAN 20, but I actually know exactly where you are. You're not an unknown unicast. I know you're out here because I had just received a frame from you. You're in my MAC address table. And that's how the packet got from here to here, routed by our distribution 1 switch. Okay. So I hope you noticed that our distribution 1 switch is acting as a multi-layer switch, multiple layers. It's acting as a layer 2 switch and as a layer 3 switch. Okay, layer 3 router. Okay. All right, let's do one more. Okay, once again, through the magic of pausing the video, we're going to go from 10.10.1.100. I got that right. Good, Rick. And we're going to go to 10.33.100 over here. All right, so let's assume, I don't think we need to show the ARP request for the default gateway again. This time, let me change my color here. This time, this device says, yes, I got to send, we're in 2 different networks. I know I need to send it to my distribution 1, my default gateway, 10.10.0.1. Oh, you're in my ARP table? Great. So I'm just going to encapsulate this packet into the MAC address associated with this IP address specifically, 10.10.0.1 on distribution 1 layer 3 switch. Comes up here, right? The switch says, oh, it came in on VLAN 10 port. I'll only send this out VLAN 10 ports. That includes any trunks. Let's say the switch does know, yeah, we get a lot of traffic going to our layer 3 switch, our router. Everybody's going that way. I happen to know where it is. So I'm going to just send it out this link here. You're not a unknown unicast. So I'm going to tag it here, received at this end here, untagged. The layer 3 switch says, oh, great. Oh, destination MAC address. Hey, that's for me. And it's actually associated with my VLAN 10 interface, 10.10.0.1. So let's go ahead. I need to route this. So let me clear that out of the way. So what it's going to do again is look at its routing table. This time, so 10.10.10.30, I've been saying 10.10.33.100. Where's that? Here we go. Oh, wait a minute here. This is via another router, next hop, 10.111.1.2. That's over here. So it knows that it needs to send it out 10.111.1.2. Now it uses something called Cisco Express Forwarding, so it knows it needs to send it out this gigabit 10/24 port. We actually can see this right here. It knows it's directly connected to that network, but it doesn't actually have to do a recursive. Don't worry about this, but the old days it had to do what was called a recursive lookup where this address is and say, oh, it belongs here. I send it out here. But now all of our layer 3 switches, routers, they run something called Cisco Express Forwarding, and all that kind of good stuff's already been pushed down into the fib and the adjacency table. Not important here. Just what you need, more stuff, right? Okay, so the key thing here is it's going to be sent out this interface here. So it gets sent out here, this packet, with the destination MAC address associated with this next hop address. Now, in case you didn't know this, routers, layer 3 switches will also have ARP tables. Okay, so if it doesn't know the MAC address of this associated with its next hop address, it will send out an ARP request, get back an ARP reply so it can encapsulate it. Okay, now the layer 2 switch has it. Okay, and it says, oh, 10.33.100. What am I going to do with this? By the way, the destination MAC address was associated with this interface here, gig 1024. So it knows that if this is a Ethernet frame, it needs to most likely try and forward the packet that's been encapsulated. Okay, that destination IP address is 10.33.100. Let's see if there's a match. I'm pretty sure there is. I'm sure you think the same thing here. So yes, I've already done this here. 10.30, here we go. That's our best match. Oh, it's directly connected VLAN 30. Well, what port or ports do I have that's directly connected to VLAN 30? I think you're getting this, right? So it says, do I have any access ports or VLAN 30 access ports or trunk links that allow VLAN 30? I do. I have 2 trunk links. Once again, it may not know the MAC address associated with this destination IP address. Do you want to do that one more time? I think so. Let's do it one more time. So in this case, this switch says, well, first of all, let me get the MAC address. So it's going to send out an ARP request. Basically, let me throw that in there, so you can see what that is. Who is 10.30.3.100? send me your MAC address. So that's going to go out both trunks here, tagged as VLAN 30. Let's go here, gets untagged here. Will not go out this port. That's not VLAN 30, that's VLAN 40. It will go out this port here, okay? Because the switch recognized came in on a VLAN, came in tagged as VLAN 30. It will be sent out this trunk link, tagged as VLAN 30, untagged by this switch. The switch recognizes it came in tagged as VLAN 30, so it will not send it out this VLAN 40 port, but will send it out this VLAN 30 port. Comes in here, this switch here, untags it, recognizes came in on a tagged as VLAN 30, will not send it out VLAN 40, will send it out this VLAN 30 port. I sound like a robot. All right. So it's going to send out this trunk link here, tagged as VLAN 30, comes in here, the switch sees it, untags it, recognizes it was tagged as VLAN 30, will untag it, will not send it out this VLAN 40 port, but will send it out this VLAN 30 port. This is the device that says, everybody else ignores it, but this device goes, yep, you're looking for me, so let me go ahead and send you my MAC address. Okay, and of course it gets tagged here, untagged here. The switch's MAC address table says, I know where the destination MAC address is that sent this out. I don't have to send it out as an unknown unicast out this port here. Okay, so now we're almost there. Okay, so now this distribution 2 switch can encapsulate it in the MAC address that it received in the ARP reply from this device here. We'll call this C. Okay, so it's going to send it from its MAC address associated with 1030.0.1. Okay, just like we saw over here, these IP addresses, these switch virtual interfaces do have their own MAC addresses sent out here, tagged as VLAN 30, untagged here. This switch receives it, says, okay, this would only ever go out another VLAN 30 port. And actually, I don't need to send it out this trunk link because I know where this destination MAC address is. I learned it when I got the ARP reply, and I'll just send it out right this port here. Yep. All right, cool stuff. And just to, you can play around with this yourself. I hope you will, but just to kind of show a couple of last things here. So I did a couple of pings here, and you'll notice sometimes we get these first pings time out. That's because ARP requests. But you'll notice, first of all, the ARP table of this device here, like any device, it will, like any typical end device, in its ARP table will only be IP addresses. Remember, so this is just normal IP. The end device has no concept of VLANs. It says I can only send from my Ethernet NIC card to another Ethernet NIC card devices that are in my IP network. So in an ARP table of an end device, we'll only see those IP addresses on the same network as the device itself. You forgot here, the IP address is, we are 10.10.1.100. So notice 10.10.0.1, 10.10.1.1.01. These are /16 networks. Okay, so we'll never have in its ARP table an IP address for a device in another network. I never like to say never. Weird things can do sometimes some weird things. Okay, as far as our layer 3 switches, show ARP. Okay, so it will learn MAC addresses. Okay, first of all, it knows. Let's just take a look at let's see, 10.10.1.100. You should see that right there. Okay, there's the MAC address associated with a device on its VLAN 10. But remember, we also sent something to 10.21.100. So because it's like a router, it is a router, just layer 3 switch. Okay, so this device, like a router, will have ARP entries for each one of its IP networks, typically, or any devices it talks to on those different IP networks, including, so there's our 10.10.0.0 network, VLAN 10 in our VLAN world, 10.20.0.0/16 network, VLAN 20, directly connected. The other one was VLAN 10. But we also have the 10.1.11, right? So this was the next hop of our other router there, distribution 2. And you can see that its MAC address, the other router, via this routed port. And if we take a look at distribution 2, it's same type of thing. Okay. It has the IP address for the other routed on, the other router via its distribution port, 10.1.11.1.1. And we also, let's move that over just a little bit, 10.33.100, it had to learn the MAC address of that on one of its VLAN 30 interfaces, which was on the trunk. So I hope this helps you understand a little bit about how all of this works. You already knew, most likely, all this stuff. It's just, you just have to ask yourself the questions. What does it know? If it doesn't know it, how does it find out? And just go through that process. Whether it's ARP, whether it's an ARP request for the broadcast, what do the switches do? And if we've implemented VLANs, access ports, trunk links, just take it step by step. Okay. And you've got it all. You can do this. All right. I hope this all helped. Really good stuff. Look forward to talking to you in the next video.